stopped here. Okay, so we're going to do some algebra review here with the exponent rules. And I think most of you will remember these rules from Algebra 1, Algebra 2. Math analysis. So same base being multiplied, add the exponents, divide, take the top minus the bottom, or if you leave it in the bottom, you would do the what? N minus the M, right? So you could also leave it in the bottom. We just want to go whichever is bigger, basically, right? Okay, here, power to a power, we can multiply. So sometimes, like let's say I had 2 to the 2n. What's another way I could have written that?
Parentheses 4.
So 4 to the n. Good. Okay, so we could simplify those things once I get, like maybe it was like 2 to the n squared or something, right? We could simplify this right here, this power to a power. So a lot of times we could do that as well. Okay, again, if it's in the numerator and negative, we can take it to the denominator. If it's in the denominator and negative, we can take it to the numerator, right, and make it positive. So we can flip-flop those things. Okay. As long as, what's the only thing A cannot be? 0. 0 to the 0 is what? Not infinity. Not undefined. Indeterminate forms. Okay? So 0 to the 0 is indeterminate. Okay, so let's look at the first one. And this is what we're going to see. We're going to have to get these reduced so we can do some things with them. Okay? So on the first one, I'm going to rewrite that as 10 to the n times 10 to the what? Negative 1. So we're kind of going backwards of the rule. Down below, I could write that as 10 to the n times 10 squared. So then what happens to the 10s to the n's? They cancel. And we're left, what am I going to do with the negative? Take it down, so it will be 1 over 10 to the third. Okay, cubed. Questions about that? Okay, so we don't just have to have numbers, we could have blobs to exponents. Okay, so my blob here is this n plus 1, it's just a blob. Do the same kind of thing. So that I'm just going to leave because there's nothing to separate it. But how can I separate the denominator, Plattner? Good. So now do you see how we can simplify that? Awesome. Okay, so on this next one, I'm going to combine the exponents with what we did yesterday with the factorials and take the limit. Because this would end up being a last step in one of the series tests. Okay? So this is something we're going to have to find. So let's see if we can simplify the inside before we try to take the limit. And some of you guys are just going to start knocking them out without having to rewrite everything. Some of you guys will want to rewrite it all. I don't care. I'm going to rewrite it just for today. Once we get going, I'll just start knocking it out. Okay? So how am I going to rewrite the 2? 2 to the n times 2 to the first. Right? Okay? And then this 2 to the n I'm going to leave. Because what happens now is that I can cancel these. Yes? Okay, what about the factorial? Which one am I going to try to simplify first? Like, which one am I going to take out from? The bottom. So I'm going to take out a n plus 1 and leave a n factorial now. And I still had the n factorial on top. So now these two guys can cancel. So I'm left with 2 over n plus 1. And now can I take that limit? What do I get out? Try again. 0. Remove 0.
Okay. All right. Something's wrong.
You're doing great. Okay? Think we can do that? Okay. Other things is when we get to alternating series, we're going to need to simplify stuff like this -1. So a -1, just like a little side note, a -1 to an even is always going to be what? +1, right? A -1 to an odd is always going to be a -1. So as we reduce these, that's what we're kind of looking for. So on this first one, I have -1. How can I rewrite it again instead of breaking it apart? Jared, go ahead. -1 to the 2n times -1 to the first. Now remember how I told us what we could do here? We could go -1 squared to the n. So what's -1 squared? Okay, so this part right here just becomes a +1. What's a +1 to any number? 1. So basically that part, what are you going to say? It's just going to become 1. Then I still have it times the -1, which would give me my final answer of that thing right there is actually just -1. Let me talk through it again. Yeah, Riley. Well, it's when I just have 1 to the n, it doesn't matter. So, okay, let me ask you this. Let's say that I had -1 to the 3n. Then I would say, well, what's -1 to the third? What's -1 to the third? -1. Can I reduce that? No. Now n plays a role, because if n is even, then it's +1. If n is odd, then it's -1. But before I had -1 to the 2n, which simplified to 1 to the n. So I mean, this guy goes back and forth between -1 and 1, where this guy is just always going to be 1. Was that my fault? I think so. Make sense? So if I have the -2 and even, it just goes positive, and a +1 to the n, that's always 1. Doesn't matter. A -1 to the n, though, I can't reduce to 1. So -1 to the n, this is my final answer. Okay? A 1 to the n, this is my final answer. And I need you to understand this now, because we're going to do a lot of reducing with this, with a lot more stuff going on. So let's pause and see if you guys want to ask questions of your peers. Or group leaders, just state it one more time.
Still false.
I don't think it works out too.
Now, I kind of walked around and I saw some things that were bad. I saw that this guy, some of you wrote it like that. Is that the same thing? No. Because that would just end up being -1. Okay? So be careful, make sure you keep your parentheses, okay? Okay, try number 6 with your buddies. Use that. Yeah, try number 6. What does negative 1 to the 12th become? 1, so I'm just left with negative 1 to the n. Okay, I'm going to throw in a 7. What if it was negative 1 to the n plus 3? Does that make sense? Okay, so those are the things, again, they're going to be important down the road. So try 5. Michael, what did you do?
I did negative 2 to the 2
Uh-huh.
times negative 2 to the 6.
Okay.
Then I made negative 2 to the 2 4. Yeah. I did that.
So this one right here is 4.
Yeah, I also did negative 2 to the 2. Like I squared it.
Uh-huh. And this is what?
4 to
Good. So it's like 4 times 4 to the n. That's what I would simplify it to. Okay? And that's going to allow me to see some other things. You could, but I like to see. So his question is, could you write it as 4 to the n plus 1? That's absolutely correct. But as we go, we're going to want to see a number in front and a number to the n power. So like just to the n power to get it simplified like that is going to benefit us more. Okay? But yes, that you could put it back together. But this helps us more. Okay. So we have this. If he said, could I write it like this? Absolutely, but it won't be beneficial for us as we get into all of our tests. Okay? Okay, so then just kind of looking at series, we have that summation sign. This is just like the index, so like if you see I, K, it's ambiguous. It doesn't matter what letter you put there, as long as like here I can see the N is here, so I replace the N's. If I had an N here, and I had this, oops, here, wait, I got it. Go ahead. I want to make sure you get this. No, finish. Okay, we're not listening. Has anybody seen Hidden Figures eat like a pizza on away? Uh-huh. Has anybody seen Hidden Figures? Okay, so right here, let's say that I had this as my series. Do I put the one, like the n, when I go 1, 2, 3, as I start putting in the integer values, right? Where do I put them in for both the n and the x variable? No. I'll only put them in for the n variable. So like as I go and do the first one here, let's rewrite that. What did I have? X. Okay. So as I go to do the first term here, that x minus 1 stays, and when I put the 1 in here, I get 2. Plus, as I put 2 in, the x minus 1 stays, and I get 3. Plus dot dot dot. Okay? So whatever's here is what I'm plugging in for n, and I go by integer values. So this is my start, this is my stop. Okay? Yeah, that's the basics. Okay. So here I said consider this series, and it's starting at n equals 2. An important thing that we want to do is to change it from starting at 2 to a simplified form of starting at 0. So oftentimes we're going to have to manipulate the starting point. So we need to think through, if I start at 2 here, okay, and I want to get to 0, I'm basically subtracting 2 to get it to 0, yes? So if I subtract 2 here, I kind of have to do the opposite, and everywhere I saw an n, I'm going to have to add 2 in parentheses, okay? So use parentheses when you are like putting in the n plus 2. And then I could simplify it down. So let's look at number 1. It started at 1, and I want us to change it to be at 0. So to get to 0, I'm going to have to do what from here to here? Subtract 1. So in all of these n's, I'm going to have to replace them with what? Yeah, and plus 1 with parentheses, and then simplify. Dave, what'd you get? Like this? What's in parentheses? Okay, and then I have and technically I don't need parentheses there, but we'll go ahead and write them. Okay, keep going, keep simplifying. So the numerator I think you can do all in one step. That'd be 2n plus 7. We can all do that, yes? Like distribute the 2 and add the 5 together. And then down here, this is going to be 3 times 3 to the n. Okay? Go to this one. See what you can do here. again, there's really not much more for that guy. We may have to end up trying to get that to the n factorial again. Okay, so we may see it like the n plus 2 times n plus 1 times n factorial that we may have to do later. Okay, but for now we're good. So if you left it as just n plus 2 factorial, great. But we do want to try to get number to the n, number times number to the n. It's the general form, right? So that's what we're trying to get it to. Okay, and last one. And again, try to get to that a times b to the n form. Emily, is that? Anybody know what form this is out for? What kind of series? Just curious. Or it's on the board over there. Just take a guess. Yeah, it is geometric. Okay, any questions on changing the starting value? Okay, so again, geometric is like you are multiplying by a number, okay? So you are multiplying. Arithmetic, you are, or multiplying or dividing. Arithmetic, you are adding or subtracting a number. Okay? So you can find the slope and adapt to that. So sometimes you're going to see this series written out as the expanded notation, and it's going to want you to get it into the series form, like the summation form. So which one of these is arithmetic and which one of these is geometric? So what's the pattern? Am I multiplying or dividing here? Well, what am I doing? Okay, so I'm adding 4. What about as I go along here? It's hard to see on the first one. But what am I doing? Multiplying by 3 halves each time. Yeah, negative 3 halves actually. So the signs are changing. The first one's weird to see. But if you ignore the first one, you can see it easier. But check the first one, does it work? Once you simplify it? Yeah. Okay, so I want to write this basically like that. So if I'm adding 4, I basically know my slope is 4. So I know I have that 4n. Okay, this is going to be in the slope. And then when n is 0, what do I need to get out? A 3. There we go. Is that okay? Let's check. Plug in 0. What do you get? 3. Plug in 1. What do we get? 7. Oops. It's a summation. Plug in 2. What do we get? 11. Does it work?
Yes.
Yes. Okay. So I'll give you a hint. This is geometric, and we're going to try to get it in the form like this. So basically like that. The A is going to be your first value. The B is going to be your what you're multiplying by. And we actually don't call it a B, this is more for X or power form, but we're going to call it an R. Okay? You want to try to write it? Now that you see that, it should be boom. What's our starting value? It's the very first one. Negative 1/3. What are we multiplying by? Negative 3/2, and that's to the end. Check and see if it works. Plug in 0. Plug in 1. Plug in 2. Does it work? Yes. Okay. Next, I think this is the last skill I have is with these absolute value stuff. Yes? Oh, no. Okay. So almost done. So how to solve an absolute value inequality when the power is just kind of 1. So when I have this n plus 2 is less than, give me a number. 6, I heard. Okay. Then if you remember, we drop the absolute value bars. So those go away. We leave that, but we also do the negative. Okay, that's a less and. We go into an and. Now be careful, because if I had this, that's a great or, we're going to see an or statement. So again, we're going to drop the absolute value bars, and we have this, or we drop, we switch, and negate. Do you kind of remember this from Algebra 1 and Algebra 2? So you have a less and, a great or. Ands when you graph are like this, okay? So on the number line, as you like see your points, they're going to be like this. You get a value, like an interval value. Well, in this case, they're open. But you'll get an interval value. Oars, I always think like you're rowing a boat. Okay, so you have these oars. They go out like that. So oars, as you graph, are going to go like that for your solutions. Okay? So let's look at the first one. I have a couple just in here. Okay, so let's do this one together. It's a less and. So ands are just one joint statement. Do you understand what I'm saying? Less and, great or. Okay, let me go back. So this right here is a less than sign with it, right? So I think less and. So ands you write as one, like a 3 kind of thing, an equality of just 1 to combine. This right here is a great or, and ors go out. And that's when I teach algebra what I do. I know how to discretion. Okay? That's how I remember. Okay, so this one right here is a less and. So it's just like one big compounded inequality. So this is less than 1, but greater than negative 1. Get n by itself in the middle. So what do I have to do to all 3 parts,
Plus the
plus 3. So add 3 and this is at 4. Add 3 and this is at 2. And then divide by 2. Okay. So this is our solution written in interval notation. Okay. This is our compound inequality. Okay. Next one. Solve for that. Could I technically multiply the 3 over first to get the value of 3? 3. So I could multiply the 3 over first, technically. So that's what I'm going to go ahead and just do first. Good? Okay. So that's basic. I'm going to teach you something I don't think you've really been doing in any other class. I don't think you've solved higher orders. So we're going to look at how to solve the higher orders graphically. Okay? So as I do this guy, I'm going to basically graph. So I'm going to graph this. So graph y equals the absolute value of x cubed. I'm going to graph this guy. So I'm going to graph y equals 1. And I'm going to look, where is this, right, smaller than, where is that guy smaller than that guy, basically? Where is it less than? That's what I'm going to do. I'm going to look at it graphically. So if I was to graph just x cubed, it would be like that. But I want the absolute value, so what am I going to do with this guy? Flip it up. Oops. Flip it up for the absolute value. So this is the absolute value of x cubed when I see it. Then I go and I graph y equals 1. Because that was on the other side. So then this is where the graph is smaller. Yes? And it just wanted less than or equal to, which works on this interval. Agreed? So what's my final solution here? Where x is between what? 1 and, yeah, -1. That would be my answer. And how would I find, if it was a weird thing, how would I find that point of intersection? If it wasn't just nice and easy that I could see. Well, we're not going to have a calculator. We're going to set x cubed equal to 1, okay? Basically, because that was the 1 here. So we just set them equal, take the cube root, and what do I get? 1. The other one, I'm going to set it equal to the negated part, that -1. So I'm going to set x cubed equal to the opposite, which would be -1. Riley, doing okay? Okay. So x would equal -1. So I can see that here. Okay? And that's where I can get those values. Okay. Graph the next one. Graph the absolute value of n squared, just like you would do x squared. And graph y equals 4. times this is easier to solve. So here's the whole time where that graph is below the 4. So I want to know what would be the interval here where that would work. Where do they intersect here? -2, where do they intersect here? 2. So there's my answer. Is that okay? Okay, last one of those. What do you think I would do before I start graphing from what I said the other day? Multiply by 8. Because the absolute value of 1/8 is still just 1/8. So I'm going to do the absolute value of n cubed is less than 8. Let me give you a weirder number. It's not a perfect cube.
Nice try.
So where do these guys intersect? Here. 2 and -2 again. Okay, group leaders, see if anybody has any questions about that. Bang wants to try one that's weirder. So let's say that I had the absolute value of n cubed is less than 4. This next one he wants to try. It doesn't give you an integer number.
This one.
Good? Okay. Last part of notes. You guys are so excited today. A little bit. I expect you guys not to ask me about all these skills later in the chapter. It's 2 days now. Okay. So now we're going to do partial sums. And this is what we've kind of already been doing. But it's like saying, like, if I only use the first term to approximate the sum of the whole series. So if I had this series going out, okay, so we said this whole series is this guy. And it started at 1. Could I adapt it? Do that for me really quick if I started at 0. Just want to see if you guys can change it again really quick. started at 0. Let's do that. Okay. So we're good at that. So are these equivalent series? Yeah. Okay. So if on a test, if I said which series are the same, you could tell me these two? Okay. Okay. So anyway, so the first partial sum is basically, we're going to denote it as sub 1. And we're going to say, hey, we're approximating that infinite sum if it went out forever and ever and ever just by the first term, and we think it's 1. Or it is 1. Okay? The second term, so we said, what? Okay, gotta reopen it. Sorry. Oh, I was recording. Is it still recording when I open and reopen? Okay. I hope it does. Okay, so here we can say S of 1 is what? Okay, S of 2, okay, sorry, this is approximating that guy. I need approximations there, fix that for me. Oh, no, hold on, I wrote 1 to 1. So I'm good. See how I wrote 1 to 1? So it's just starting at 1, ending at 1. Good. Okay. The second, just partial sum using 2 would say I'm going to take the first term and the second term. So I go from 1 to 2. And what would that equal? 5 fourths, so 1.25. Okay. S of 3, you'd add the first 3 terms. So you start at 1, end at 3. And so what would S of 3 be?
1.361.
Just do that in your head.
Yes.
Because you added 0.11.
Yeah,
that's smart. Okay. Oh. No, so he did that. 1/9. You guys should all know your ninths, by the way. 1/9, 0.1. What's 2/9? 0.2 repeating. 3/9. 0.3 repeating, right? Okay. So he just took that guy and added 0.1 repeating to that decimal. Get on the ball, you guys. I'm so proud. Okay, so then the nth partial sum, like if I went out to infinity, that's what I would kind of be looking like. What if I wanted to keep going, right? To go all the way out. And that's what we're going to try to find, is we are trying to see if we get a number, okay, as we go out forever. So here it says, find the nth partial sum for the given series. So try for n equals 2 and tell me what you guys get. And try for n equals 3 and tell me what you guys get. And you don't have to write like the summation from 1 to 2. Just put S of 2 equals, give me a value. What'd you all get? 1/2. What'd you get? So you said? So S of 2 would be the first and the second terms. Yeah. S of 3 is going to be the first, the second, and now the third. So we're just adding on 1/4 to 1/2, and we got 3/4. So does this summation appear to converge if you kept adding and adding and adding values? Try it. Get your calculator out. Tell me what you think this summation converges to. think the sum is bigger than 5? How many of you think it's less than 5? How many of you guys think it's more than 2? How many of you think it's less than 2? How many of you think it's more than 1?
I know what you said. The final answer.
Less than 1? How many of you think the final one is more than a half? Less than a half?
I think just a half.
Okay, you think just a half. Okay. So we're narrowing it down. Looks like the majority of you think it's going to be somewhere in the interval from 1/2 to 1. So who's got a good estimate? Who's went out for a while? How many terms did somebody go out to? S of what? How many terms? Anybody got 10 terms?
Okay, I got it.
Huh? You're adding. 1, 2, 3, 4, 5, 6. Did anybody find S of 6? Just the first one's up there without having to write any more of the pattern by yourself?
Not that hard.
Okay, everybody go find that. Oh my gosh.
Not that hard. It's like 65, 62.
0.65 what?
62.
625. So that's what he got for S of 6. Anybody get S of 10? So just add on a few more to that. S of 8 is what? Ish. Okay. Anybody want to guess what it's going to converge to? 2/3. Okay. Okay, it does. It converges to 2/3. So let's look at this guy right here, this pattern, and let's write that as our series. We just did this a second ago. Is this arithmetic, geometric, or neither? It is a geometric. What's our first term? 1. What are we multiplying by each time? -1/2 each time? So is that working so far? So if I wanted to find what this converges to, does anybody remember how to do this with a geometric series? Okay, well you're going to find that out. But it should equal 2/3. Okay. You're going to find out how as we go along. Now I've got to pique your interest, right? Okay.